So let's talk about this $32 book. It's $32, and then what happens to that $32, Connor?
You gotta minus 8 because it's one.
Okay.
It's a fourth. So
I'm going to choose to multiply by 0.75 myself.
you just do
You're losing a fourth, is what you're saying. That leaves us with
24.
3/4. So this would give us how much money?
24.
$24. But then,
And then you
lucky you, there's a 25% coup. I like the coups. And so, Connor, what am I going to do here?
Then you gotta times 0.75 again, and it's minus 6 off. And it equals 18.
That book went from $32 to $18. What a deal. Evan. So you're saying if I multiply by 0.75 twice, I could do 0.75 squared? Yeah, you could.
Wow.
This is the same thing. Times 0.75 times 0.75. You could do this. It's the same thing as 32 times 0.75 times 0.75. Cool. Evan's making a little connection to what we've been doing. Talk about this $450 computer. Who can tell me how much? I'm less interested in how much she owes after 1 year. More interested in the expression you use to get your answer. So who can give me the expression that they use to get their answer?
450.
Cool.
450 times 1.18.
You did 450 times 1.18. Did anybody do 450 plus 450 times 0.18? That also gets you there. So this gives you the total because 100% is the starting amount. 18% increases the 0.18. So 450 times 1.18 is $531 owed at the end of the year. That's just extra money this person's got to pay, right? So assuming that this continues, at the end of 2 years, I'm going to take that 531 and I'm going to multiply that by 1.18. And you can just keep your answer in a calculator and click times 1.18 in this case.
You can just use an exponent.
You can use an exponent too. So that's 2 years, 620, 658 times 1.18. After 3 years, $739.36. So that computer is getting pretty pricey if we don't pay it back, right? It costs money to borrow money. If you find a 0% loan, take it off. All right? Yeah. To find the amount owed at the end of the 3rd year, the students wrote this. And this is essentially what we did, right? Multiply times 1.18 times 1.18 times 1.18. Does this expression show the correct amount? Yes. I'm going to say something like she multiplied by 1.18 3 times. So that's cool. And then I'm guessing you guys know some stuff. Noah, did you get an expression that you used to simplify it up a little bit?
Yeah, 450 times 1.18 to the x.
Yeah, we've seen this before, right? So instead of like 2 times more, 3 times more, half, we've got 18% increase. We know 100% is how much change?
0.
No change. 18% more is 1.18. Do you guys know what it's called when we multiply by 1.02? No. 2 change. It's a rapper joke. Okay. Come on, Connor. I thought you'd be the one to get the 2 change joke. So more interesting things. We're going to compare loans now. I don't know if you know this, but there's loan options. Our 3 loans here are 12%, 24%, and 30.6%. Obviously, which one's the best loan if you're trying not to spend money? 12%, right? So these 3 people, they've taken $1,000 loans, but they're all paying different annual interest rates. So this is compounding only once a year, each year. For each loan, you're going to write an expression, only with multiplication. So we're going to work on making that exponential function. It says use graphing technology. We're not going to graph it. I'll graph it and we'll all look at it. And then, but what you'll be able to do, and we'll look at the graph to answer number 3 together. But what I want you to do, instead of graphing it, just imagine how the graphs are to look compared to each other. Actually, let's just do that together. These 3, how do you know which one would be which if you just looked at a graph? And like not labeled or anything, just looked at a picture. How would you know which one's which, Raphael?
The loan C will be like the highest slope up.
Go up the steepest, yeah.
Loan B will just be in the middle, and loan A will be like on the
Yeah,
lowest.
Goldilocks that sucker, right?
Yep.
Steep, middle, less steep. Where are they all going to start? 1,000. All right, so I want you to get these 1, 2, 3, 10 in X years, write an expression for each, and then we'll look at the graphing technology together. We're going to start rolling through this. So loan A at 12%. I'm going to multiply by 1.12. I'm going to tell you what I'm doing in my calculator. I'll save you time. 1.12 to the 1. I know we don't need to the 1, but that pumps out 1,120. The reason I like that is in my calculator, at least, I can push the up button to get back to where I was typing stuff and just change the 1 to a 2 and hit enter. 1,254.4. Yeah, it does. I think, or you might be able to hit there's something else. I can work with you on it. Then I go change my 2 to a 3. And I got 1,404.93. Go up, change it to a 10. 3,105.85. Man, oh man, that got expensive. So who can help me out with the expression for loan A? Noah.
1,000 times 1.12 to the A.
So I'm going to do f of A equals 1,000 times 1.12
To the A.
to the, I'm going to do to the y for year, but yeah, same idea. You got the right idea. That's what I'm going to do for that first one. All right, so loan B, what's the only difference? Instead of 1.12, I'm going to do 1.24 to the 1.
Why isn't it X instead of Y?
I did y for years. Oh, I said f of A right there, so this would need to be an A, though. I done messed up, guys. I'd have to do an A there, if I did an A there. Whatever. You know there's a variable. Okay, so 1240. I'm going to go change that up to a 2, and that gets me to 1537.60. Go 3 years on it. That gives me 1,906.62. Go slap 10 years up on that, and I've got 8,594.43. Do you see how those people that get in trouble with debt, it's hard to fix?
Yeah.
Look at that $1,000 turned into $8,500 in 10 years. Now, if you can make 24% on something, though, your $1,000 can become. All right, someone help me out with the function. Let's do f of b, or I don't like that I did f of a there. Let's do g of x. We'll do x and y on this one. This is for the 24%. Who's Orly? You got it for me?
Yeah, G of X equals 1,000 times 1.
Maybe Shaq just throws it on the screen.
Oh, that's up there. I was writing right here, Raphael.
Oh.
Okay. Loan C, the 30.6%. Oh, man. So 1.306. After just 1 year, guys, this one is 1,306. So imagine being hit with that percentage on a credit card thing that you owe money on. That's why people will be like, beware of credit cards. Because some people spend money they don't have with them, and then this is what happens to your money. You owe all this extra money. $1,700 already? Let's go 3 years. Debit card's different. Debit cards can only take out money that you have in there.
I have it.
You can go 10.
Actually, I used to.
It's already $2,200 after 3 years. Uh-oh, I don't even want to look at this 10-year. Do you guys? I'm getting anxious. Just
It's really big.
this isn't even really my money. 14,000?
Wouldn't it be 5-1?
No, 49 cents would round to 50 cents.
Yeah, but the one behind it would make it round.
Yeah, but you don't round up from the one past the one that you're past.
Oh, okay.
That sounded more confusing than what it actually is. Okay, h of x. Who can give me a function for that last column, that 30.6 hitter? Raphael.
H of x equals 1,000 times 1.306 to the x.
Whew. So look at what that. What do you notice instead of going looking at the double thing? What do you notice about the common differences over and over? Like compared each one. Like what are you noticing? How could you explain what's happening to the numbers?
Bigger than percent.
got that jump right there. Like, there's a difference, right? It's not crazy, though. It's a little crazy on the third one still, almost a third more. But look at this jump. 1 to 3 versus 1 to 14. What's going to happen with the jumps if we compare the same time periods forever? Like another 10 years, is it going to be bigger jump comparatively or less of a jump? Bigger, and because we know how exponential functions work, right? So you guys got to use that data. You're going to help me. We're going to do this one kind of together. So for each loan, we're going to find the average rate of change per year from start to second and from the end of the 10th to the end of the 12th, okay? I'm actually going to choose, we're just going to do the middle loan. So the middle loan was g of x equals 1,000. What was my rate again? 18? 24. Okay, so that's my loan. So we're going to find the rate of change between the start and the end of the second year. So the start is how many years for x? I'm getting organized. What am I starting at? This is the easy question. 1,000. And at the end of 2 years? How much was it at the end of 2 years?
1,000.
You got it on your table.
200.
Wait, loan B?
Yep.
1,500. No. Yeah, 1,537.6.
Okay. So, to find the rate of change, I'm going to subtract these, right? So it changed by 537.60 over how many years? Over 2 years. So 537.60 divided by 2 is 268.80. I'm going to circle that. So that's how much is changing per year for the first 2 years. Now, same loan. Actually, I need more space. I'm going to write it up here. 268.80. Same.
537.60?
No, from 1,000, right? It went up 537.60 over 2 years, which would be this much per year. Okay? So the next thing I need to compare is year 10 and 12. Whisper, while I'm setting this up, whisper to your neighbor a prediction for year 10 to 12.
It's probably going to be...
Okay, so year 10, I'm going straight calculator. 1,000 times 1.24 to the 10. Oh, yeah, 8,594.43. And year 12, I just need to change the 10 to a 12. 13214.79. Okay, so to get my average rate of change, I'm going to find the difference. And I'm going to divide, how many years was this one over? Year 10 to 12. How many years? 2 years. Okay. So 13,214.79 minus 8,594.43. Divide by 2. Whoo. 2,310.18.
Yay, I was right.
So this was the average rate of change for 2 years. Now this is the average rate of change for those 2 years. What do you expect is going to happen to the average rate of change as the years go by?
Bigger and bigger.
Bigger and bigger, because this is not linear. It is exponential. Really, the only difference, friends, that we're doing with these exponential functions is we're dealing with percentages instead of multipliers. But the percentages are a multiplier, right? Like, we good with that? I've been kind of throwing them in there. You guys notice that in hindsight? Yeah, that's on purpose. All right. That's fun. Let's see. Let's make sure we can use this. We can use graphs. We already understand the graphs. We had a whole lesson. We can imagine what the graphs look like compared to each other, right? Can we write expressions to represent percent increase repeatedly? Using percentages even?
Yes.
You can do it.